Okay, so in this video, we are going to have a quick look at the evolution of the Earth in terms of 4 topics. So first we look at just, how the Earth is layered. It has a layered structure. Second, we look at how was lithosphere developed. We then look at the evolution of the atmosphere and the hydrosphere. And then finally, a quick look at the origin of life. Now, if we look at the layer of the Earth, we observe it is you can quite see some layers, right? You can understand that there are layers. Now it's important to know that the planet Earth was a very barren, a rocky and a hot object with just a very thin atmosphere of hydrogen and helium. And this is far from the present day picture of this beautiful Earth with its oceans and forests and land and so on. So there must have been some events or processes which will have caused this change from rocky, barren and hot Earth to a beautiful planet with ample amount of water and conducive atmosphere for favoring the existence of life, right? That's what makes us possibly to live on this planet. So now in this, that's what we are going to find out, how that in the period between 4,600 million years to the present led to the evolution of the planet. The Earth does have a layered structure. From the outermost end, which is the atmosphere, to the innermost end of the Earth, which is like the core of the Earth, we know that the material that exists is not uniform. The atmospheric matter has the least density. And as you go from the surface to the deeper depths, the Earth interior has different zones, and each of these contains materials with different characteristics. So the question is, how was the layered structure of the Earth developed? So the Earth was mostly in a volatile state during its primordial stage. Then due to the gradual increase in the density, the temperature inside has increased. Now, as a result, the material inside started getting separated depending on their densities. So this allowed heavier materials like iron, for example, to sink towards the center of the Earth, and the lighter ones to move towards the surface. And with the passage of a long period of the time, as the Earth cooled more, right, and it solidified and condensed into a smaller size. And this in turn later led to the development of the outer surface in the form of a crust. So during the formation of the moon, due to the giant impact, the Earth was further heated up, and it is through the process of differentiation that the Earth forming material got separated into different layers. So starting from the surface to the central part, we have layers like the crust, the mantle, the outer core and the inner core. And from the crust to the core, the density of the material increases. We will of course discuss all these detail in the properties of this layer in the following topics. Now, if we look at the evolution of the atmosphere and hydrosphere, we can think about it in terms of 3 stages. Now, the present composition of the Earth's atmosphere is chiefly contributed by nitrogen and oxygen. But in terms of the 3 stages in the evolution of the present atmosphere, the first stage is actually marked by the loss of the primordial atmosphere. The second stage involves the hot interior of the Earth contributing to the evolution of the atmosphere by a process called degassing. And finally, the third stage is what changes the composition of the atmosphere by the living world through a process of photosynthesis. So moving back to the kind of a stage 1, right? The early atmosphere with hydrogen and helium is supposed to have been stripped off as a result of the solar winds. And this happened not only in the case of Earth, but also in all the other terrestrial planets, which were supposed to have lost their primordial atmosphere through the impact of solar winds. Now, during the cooling of the Earth, gases and water vapor were released from the interior solid Earth. This started the evolution of the present atmosphere. The early atmosphere largely contained water vapor, nitrogen, carbon dioxide, methane, ammonia, and very little of free oxygen. The process through which the gases were output from the interior is known as degassing. Continuous volcanic eruptions also contributed to the water vapor and gases to the atmosphere. Now, as this Earth cooled, the water vapor released started getting condensed, and the carbon dioxide in the atmosphere was dissolved in rainwater, and the temperature further decreased, causing more condensation and more rains. The rainwater falling onto the surface got collected in the depressions to give rise to the oceans. So the Earth's oceans were formed within 500 million years from the formation of the Earth. And this tells us that the oceans are as old as 4,000 million years. And sometime around 3,800 million years ago, life began to evolve. However, around 2,500 to 3,000 million years before the present, the process of photosynthesis evolved. Life was confined to the oceans for a really long time, and oceans began to have contribution of oxygen through the process of photosynthesis, and eventually oceans were saturated with oxygen, and at around 2,000 million years ago oxygen began to flood the atmosphere, which kind of marks the beginning of the origin of life. So the last phase in the evolution of the Earth relates to the origin and evolution of life. And it is very clear that the initial or even the atmosphere of the Earth was really not conducive for the development of life. Now, modern scientists, they refer to the origin of life as a kind of a chemical reaction which first generated complex organic molecules and assembled them. And this is very interesting because this complex assemblage of molecules was such that these molecules could duplicate themselves, converting inanimate matter into living substance. Now, the record that life has existed on this planet in different periods is found in rocks in the form of fossils. And the microscopic structures closely related to the present form of blue algae have been found in geological formations that are much older than these were some 3,000 million years ago. So we can assume that life began to evolve sometime around 3,800 million years ago. And of course, you can do a quick Google search to get a very good idea of how and when life evolved from the unicellular bacteria to the modern man in terms of the geological time scale.